Hello, I'm Roman. There is an interesting video that was released, I think, in the beginning of this video, but I just saw it. It's a part of the long conversation with Jonathan Blow, a video game designer and an indie developer, and we will take a look at one specific part from this conversation right now.
I think there's a pretty serious problem that started happening in programming culture. I mean, it's been in programming for as long as I've been in, and this is beyond games even. This is everywhere. Yeah. People don't have a clear picture of what knowledge is deep versus what knowledge is shallow, right? So if you go to school and you're a good student and you learn the difference between n log n and n squared, right? That's deep knowledge that will apply in many cases, and it's something fundamental about computers, right? On the other hand, if you go on Hacker News and read an article about somebody learning a specific JavaScript API and tutorializing it, right? That's very shallow knowledge because it's just, you're learning about arbitrary decisions that somebody made about how to interface with a thing that you're not even trying to understand, right? But that knowledge became very popular since, let's say, since 2005, once this second boom of programming happened and everybody realized, oh, you can make a lot of money in programming or whatever, all these people showed up and they just want the job where they could do JavaScript, and so they just learn the API, right? And so there's been a deluge of shallow knowledge. It's a little bit more complicated than that because part of the way that you learn deep knowledge is by looking at shallow things and reading the pattern underneath. Like, if there's an API to do something, if it's a good API, then by looking at the API choices, you can understand the problem and the mechanic. Even if you can't see the code, it's better if you could see the code inside. But if you can't, you can still see some things about the mechanics. And you know, one example of that is a graphics API. It's like, okay, they want me to like put the vertex data into a buffer and like lock the buffer and then not touch it. Why is that? Oh, it's going to the GPU and all this stuff, right? You can figure this out. On the other hand, if it's a bad API, which most APIs are, it'll be full of stuff that's stupid.
People don't have a clear picture of what knowledge is deep versus what knowledge is shallow. So the deep knowledge is the knowledge that you can reuse across the whole tech industry, or it gives you an understanding of how certain things are kind of working inside. Shallow knowledge could be just yet another framework that was yesterday released and everyone will forget about this one in the next couple of years. I'm not fully agree with his statement that learning another API of maybe another framework or the library is always a shallow knowledge, because some of the frameworks or the libraries can actually force you to go in deeper into certain things, like for example the example of working with the GPU buffers. I'm not sure you can stay on a very high level without understanding how it actually works. On this channel and on my second live coding channel, I'm trying to push the idea that the foundational or this deep knowledge is actually essential and the foundation to be in the tech industry and, for example, to be a good software engineer. And the fact that it's an important knowledge, and the main thing it will never get old. Like, the approach I'm advocating is that you need to know like what is happening inside in order to use all of these frameworks and the tools more efficiently. Just an example, somebody learned another framework, for example React or something else, without understanding why it actually needed. It's actually interesting that how many things you can implement with like vanilla, even the JavaScript or vanilla ecosystem that your language provides to you, and sometimes you don't actually need that many third-party dependencies to be able to implement the things that you need. You need to use most of the frameworks like consciously, so you understand why you actually use them, not because other people use them or because they are popular, but you actually understand what is the problem this framework solves to you. I'm not telling that using the framework or like the third-party tools, other libraries, is a bad thing, but just keep in mind what problem it solves to you. It could be that maybe you don't have time to implement something specific and you can just take the library and it will solve all of the things for you. Or you're going to use the framework that's maybe very opinionated framework that kind of dictates to you how you should structure the program, and you're fine with this, and that's okay. And yeah, I keep telling that the foundational stuff won't go anywhere. For example, on the second channel, I started to showcase how I started to learn Golang programming language, and I passed the tour of the Go, the official tour of the Go from the Google, and in the end of this short series of the tasks, there are some suggested videos that they suggest to watch. And it was interesting that the person who described how the Go routine works mentioned a specific paper. I think it's named Communicating Sequential Processes, that describes most of the current implementations of the concurrency. Can you guess the year when this paper was written? It was written in 1978 by the person named Tony Hoare. I hope I pronounced it correctly. It's more than 40 years ago. And during that time, even set of the popular programming languages was very different from what we have today. And still we're using the ideas and these foundational things from that many years ago. I mean, in the tech industry, every 10 years is a whole new world. So using something from 40 years ago sounds like we're using some old thing. I think for me there are two actually fascinating examples. This is the first one about the explanation of how the Go routines works in general, and the second one is this whole AI area with the machine learning. Most of the things, like the foundational things about the machine learning, were described and invented like many years ago, even not in this century, like in 20th century. It's just, specifically for the machine learning, they didn't have back then so much compute power that we have right now. The idea is the same. The foundational stuff won't go anywhere. So why I keep telling this? Don't ignore the foundational stuff, for example, in software engineering. It's not only about the algorithms and the data structure, how for some reasons many people think of the foundation only about the algorithms and the data structure. There are way more things like those examples. Once you learn a lot of this, for example, like design patterns, things like how the concurrency works, it's easier to find those patterns in other programming languages, in other areas, and it's actually much easier to shift and explore and navigate through the tech industry and all of these changes. And with this short video, I wanted to tell that if you have doubts, if you need to learn some foundational stuff for being a software engineering, my answer is yes. Don't ignore them, continue to learn them. They will stay with us for a long time. And if you're willing to stay in the tech industry for a long time, you will need those knowledge, and it will make your life easier in the future. But for now, thank you for watching, and I see you in the next video. Bye bye.